recording. Well, yesterday we have done a problem on how to show that some function is a solution to the scalar wave equation. Now we have today we have another exercise for your in order to remind you. I will show yesterday's exercise. Here we showed that the function yxt equal to 1 over 2 x minus vt square plus x plus vt square is a solution to the scalar wave equation. Here we showed this how to proceed with this. Now we have similar problem. Please try by yourself to do this problem. Okay, after we will discuss together. Here you need to show that the function yxt equal to cosine x minus wt plus cosine x plus wt is a solution to scalar wave equation, and b, what must be the speed of propagation of the wave in this case. Okay, try to do by yourself, and after that we will discuss together. Just for the reminder, I will write the scalar wave equation, which is dy squared dt squared equal to v squared d squared y dx squared. This was the equation for scalar wave or scalar wave equation. You need to show that this function is a solution for this equation, and you need to find that what must be the speed v, speed of propagation of a wave in this case. Okay, please try to do by yourself. After we will discuss the solution. We will discuss your solution. And first, at the very beginning of the of our chapter, we said that the solution for the wave equation has the general form. The general form of solution of the wave equation is gx minus vt plus f x minus vt, and sorry, here plus, here should be plus, and we see that this equation is exactly in this form. Is exactly it is the sum of two functions. First function is a function of x minus vt. Second function is a function of x plus vt. That's why we can say that this is the solution. This can be a solution to the scalar wave equation. And in order this function to be the solution, speed of propagation should be equal to w. Okay, that's it. Simple. Okay, now the next problem. Okay. This one is also not so difficult. So try to solve this this problem also by yourself. Well, Now we will solve the problem together. Okay, first of all, the first question is asking about the amplitude, fre frequency, and speed of propagation of the wave. Well, if we look to the electric field intensity equal to x, okay, x multiplied 100 multiplied by cosine 10 to the power 6 t minus 10 to the power 6 square root of mu 0 epsilon 0 z. Okay, we can see clearly that uh, the electric field intensity E, is a harmonic function about the fact that it is harmonic is saying the function cosine omega t. It is harmonic function and its amplitude is 100. So E0, or the amplitude of the wave, is 100 because it is field intensity volt per meter. And now, what about the frequency? Uh, in order to find the frequency, we need to uh, remember the how do we write the harmonic functions. The general form of harmonic function is that in our case x E0 is amplitude cosine omega t plus phi. This was the general form of harmonic function. From this general form, we found that E0 was 100. Yep, E0 we found as 100, and if we look here, we can notice that omega t is equal to 10 to the 6 t, or in other words, okay, in other words, omega is equal to 10 to the power 6. And what about frequency? Frequency is omega over 2 pi, which is 10 to the power 6 over 2 pi. So let's compute 10 to the power 6 divided by 2 divided by pi. 159 kilohertz. 159 kilohertz. Okay, the amplitude of the wave is 100 volt per meter. Frequency, okay, amplitude we found. Frequency 159 kilohertz. What about the speed of propagation of the wave? What about this? In order to find speed of propagation of wave, we will take the equation of equation of the vector wave, we take the equation of vector wave and apply it to our electric field in order to find the speed of propagation. Okay, so let me write in a new page. So we have d squared electric field over dz squared minus 1 over v squared d squared electric field over dt squared is equal 0. So in order for the sake of simplicity, let me copy electric field to the page of our problem. Okay, let me put it here. Okay, somewhere here. Great. Okay, now let us compute this. Second derivative of electric field with respect to z. Okay, what we have? D squared dz squared x 100 cosine cosine 10 to 6 t minus 10 to 6 square root of mu 0 epsilon 0 z equal. If we take a second derivative, from this function with respect to z, okay, here I forgot one more bracket. With respect to z, what we get? X is okay, is constant. 100 is also coefficient. We have multiply 10 to 6. So 10 to 6, 10 to 6 goes 2 times, and we have 10 to the 6 square root of mu 0 epsilon 0 to the second power, and cos the derivative of cosine is minus sine, and derivative of minus sine is minus cosine, so minus cosine 10 to the 6 t minus 10 to the 6 square root of mu 0 epsilon 0 z. Okay, this point, is this point clear to you? We computed first term, which is second derivative of electric field intensity with respect to z, which is equal to this. Is this point clear to everyone? Now we move to the second term, or okay, okay. In that case, let me compute in other way. So okay, Look, we need to take the second derivative of electric field intensity with respect to z. Okay, let's put instead of E this one, and what we have, d squared over dz squared, and x multiplied 100 multiplied by cosine 10 to the power 6 t minus 10 to the power 6 square root of mu 0 epsilon 0 z equal. Okay, x multiplied by 100 is a coefficient. That's why we may take this out of the derivative. X multiplied 100 multiplied what we have now, d squared dz squared cosine 10 to the 6 t minus 10 to the 6 square root of mu 0 epsilon 0 z. Okay, now we need to take a double derivative from cosine. We need to take double derivative from cosine. First, let's take first derivative. If we take first derivative, what we have? Here we have x multiplied by 100. If we take first derivative, there remains only dz. Okay, derivative of cosine is minus sine, and derivative of argument with respect to z is 10 to the power 6 multiplied square root of mu 0 epsilon 0. Okay, minus sine multiplied by okay, first let me write the derivative from argument. Derivative from argument is minus 10 to the 6 square root of mu 0 epsilon 0 multiplied derivative of cosine is minus sine. So this minus will become plus sine 10 to 6 t minus 10 to 6 square root multiplied by z. Okay, inside of square root there is mu 0 epsilon 0. And now let's go to a new page. Now equal. Now let's take the second derivative. First, let me write these terms outside of bracket. X multiplied. This is 10 to the power 2. This is 10 to the power 6. 10 to the power 8 multiplied by square root of mu 0 epsilon 0 multiplied the derivative with respect to z of sine 10 to 6t minus 10 to 6 square root of mu 0 epsilon 0 z. Okay, now we need to take derivative of sine with respect to z again. So x is here 10 to the power 8 multiplied mu 0 epsilon 0 multiplied. The derivative of argument is minus 10 to the power 6 square root of mu 0 epsilon 0, and derivative of sine is cosine. Equals square root of mu 0 multiplied by square root of mu 0, mu 0 epsilon 0, mu 0 epsilon 0 gives us mu 0 multiplied by epsilon 0. 10 to the power 8 and 10 to the power 6 gives us 10 to the power 14. Okay, 10 to power 6, 10 to power or 10 to power 8, 10 to power 6 gives us 10 to the power 14. Here is minus, of course. Square root, and square root gives us square, and it means mu 0 epsilon 0 multiplied by cosine 10 to the power 6t minus 10 to the power 6 square root of mu 0 epsilon 0 z. Okay, we found what? We found the second derivative of electric field with respect to z. Now, similarly, you need to calculate in a similar manner, you need to calculate the 1 over v squared multiplied d squared e dt squared. Okay, Jawahar, look here. Here, this is the uh, this is the final expression for second derivative of electric field intensity with respect to z. Okay, in a similar manner, you need to find second derivative of electric field intensity with respect to time and multiply it by 1 over v squared. Okay, try to do this derivative by yourself. You have a 10-minute break, and after that we will continue.